8.4 example 4. In this example, we're going to look at another improper integral and how to go ahead and set that up and solve it. So when we look at this integral, we know we're going to need to do integration by parts because we have two separate functions. Before I even set up the integral by parts though, I want to set this up as a normal integral and not an improper one. So in order to do that, I take the limit as b approaches infinity, and then I replace the infinity with a b. And what that does is give me two constants that I can integrate between. So now I need to use my integration by parts, and I'm going to let u equal x, so du is dx. I'm going to let dv equal e to the negative x, which makes v negative e to the negative x because of the chain rule. So now we're going to set up our integral, and it's uv, so negative x e to the negative x, minus the integral of v du, so negative e to the negative x dx. So it's negative x e to the negative x plus integral 1 to b e to the negative x dx. So when I integrate, I get negative x e to the negative x minus e to the negative x from 1 to b. So use a little bit of algebra to clean that up. You don't have to, but it's going to make plugging the b in much easier. So now I'm just going to plug everything in. I get negative e to the negative b plus 1, minus negative e to the negative 1 plus 1. So this becomes negative b plus 1 over e to the b plus 2 over e to the 1. Okay, so now that I have that worked out, we have to move on to our next step, which is to evaluate the limit. So remember, we let the limit as b approaches infinity, and it's negative b plus 1 e to the b plus 2 over e. Now we know that e to the b is going to grow much faster than b plus 1, so this whole thing becomes 0. So then my final answer is 2 over e. So therefore we get that the integral from 1 to infinity of x e to the negative x dx equals 2 over e. So the first thing I need to do is write it as a proper integral. So it's the limit as b approaches infinity from 1 to b x e to the negative 2x dx. The next thing I'm going to do is I'm going to integrate this by parts. So I get u equals x, du is dx, dv is e to the negative 2x, so v is negative 1/2 e to the negative 2x. So I set up my new integral, and it's going to be negative 1/2 x e to the negative 2x minus the integral of negative 1/2 e to the negative 2x dx. We just clean that up a little bit. Okay, then we're going to integrate one more time, and it's from 1 to b. So I do like to factor out any terms I have in common. That usually makes things easier. Not always, but usually it does help. So I'm going to factor out a negative 1/2 e to the negative 2x. So I'm left with an x here plus 1/2. So then I plug it all in. I get negative 1/2 e to the negative 2b, b plus 1/2, minus negative 1/2 e to the negative 2, 1 plus 1/2. So clean that up. It becomes negative b plus 1/2 over 2e to the 2b plus 1 plus 1/2 over 2e squared. And 1 plus 1/2 is just 3/2. So this is negative b plus 1/2, 2e to the 2b plus 3 over 4e squared. Cleaning up those fractions a little bit. Then the next step is to take the limit. So we're going to have the limit as b approaches infinity. And again, e grows faster than b, so this whole thing goes to 0. So I get this is equal to 3 over 4e squared. So I get the integral from 1 to infinity of x e to the negative 2x is equal to 3 over 4e squared.